Assalamualaikum and good morning. We are from Group C48. We would like to introduce our project, which is Multistage oil trap with Kapok fiber filter. Before we start the presentation, allow me to introduce the group member of this project. The first member is Hiza Harid bin Muhammad Makran. The second member is myself, Taufik Hidayat bin Muhammad Rasul. And the last member is Muhammad Imran bin Osman. Also, thank you to our supervisor, Encik Tuan Muhammad Hafiz bin Tuan Ibrahim, who helped us a lot to complete this project. And we also would like to welcome our panel today, Encik Mahmud Abdul Hakim bin Muhammad and Encik Ghazali bin Qadis. Next, let's start with the introduction. I would like to talk about water. Water is a natural resource that is important in our life. Good water quality helps to maintain the health of our environment and our own quality of life. In the development of the world and countries, water is becoming more polluted by human activities day by day. Water comes from different sources such as rivers, lake and sea. For your information, our project has linked with FTK team. My supervisor, Encik Tuan Muhammad Hafiz bin Tuan Ibrahim, collaborate with FTK team to face the problem in Muar, Johor. The problem is the rate of water pollution is increasing day by day in Muar, Johor. Interesting fact about the city of Muar, the city has been selected as the cleanest tourist city in ASEAN. Majlis Perbandaran Muar MPM was awarded the ASEAN Clean Tourist City Standard Award 2017, which was presented during the ASEAN Tourism Forum 2018 meetings in Chiang Mai, Thailand. We plan to propose this project to MTM to help them achieve their goal of making Muar a cleaner city as before. We will help MTM by make sure that the wastewater coming out from the restaurant and fruit processing industry through the rain to the river is clean and free of oil. Okay, so let's continue with the problem statement. Food waste generated by restaurant, cafes, hotel, bakeries, school and college could end up with these three problems. Water waste problem, pipe clogging and bad smell. We know that the restaurant and food processing industry are the main source of oil waste. The wastewater thrown away from this place is very dirty and oily. Pipe clogging happens because the oil will coating our pipe wall and start collecting food crumb. It will get thicker and harder by time and cause the pipe clogging. Next, this problem will lead to air pollution coming from the unpleasant and uncomfortable smell of oil waste that is left and not cleaned over a long period of time. Next, the objective of this project is to develop a prototype of filtering device to solve oil problem by using Kapok fiber. And last but not least, the scope of study for this project is we focus on develop a prototype of filtering device by finding suitable design and requirement need to create a good and efficient filtering system to solve oil problem in restaurant and food processing industry. Now, we already know what is the problem. Let's move to the next section of this presentation, the solution for the problem mentioned earlier. The filtering device that we designed to solve the problem is an oil trap, but not a regular oil trap. We call it a multi-stage oil trap with Kapok fiber filter element on it. We have made some improvement and add special criteria to increase its effectiveness as a filtering system compared to a regular oil trap. This project oil trap has 3 levels of chamber and we add Kapok fiber filter at outside of it. So, what is oil trap? Oil trap is a device that collect and reduce the amount of oil that enter to the main sewer. These are the 3 main materials that we use to make our multi-stage oil trap. First is acrylic sheet, the second one is PVC pipe, and the third one is Kapok fiber.
Okay, so first material that we use is the acrylic sheet. This project, Greasetrap, has 3 levels of chambers. Acrylic sheet has been used as the wall for this project because of its specialty compared to other materials such as plastic, stainless steel, and glasses. Acrylic is 50% lighter compared to glass, plastic, stainless steel. It has high resistance to chemical reactions compared to other plastic materials. It is easy to shape and clean the oil and grease inside the multi-stage grease trap. Acrylic is also more elastic than glass, and it makes it easier to be cut and drill holes like we did to our grease trap. The elastic nature of this material also makes it more resistant to water impact, which will be able to withstand high water pressure and not easily broken. So the next material is the PVC pipes. So for good water drainage, this project used PVC pipes because while we're dealing with water, we must ensure that the material used does not rust easily. PVC pipe production cost is very low, so we can say it is cheap and affordable. Although it is cheap, the PVC pipe has high strength and high rust resistance. Furthermore, the PVC pipe surface is smooth, so there will be no corrosion effect, and the efficiency of the water flow will be smoother, and the water can move easily throughout the chambers inside the oil trap. So last but not least, the material that we use is third material, which is the Kapok fiber itself. Kapok fiber, it is obtained from the seed hair of kapok trees called Ceiba petandra. The kapok fiber is hydrophobic. Hydrophobic literally means the fear of water. So it does not absorb water, but it can absorb oil. So from the research that we made, citations from Zhang et al. 2015, the researchers have paid their attention to kapok fiber since 2010. And in recent years, more attention has been focused on kapok fibers, promising application as one kind of powerful oil-absorbing material due to its intrinsic hydrophobic lipophilicity due to the attached wet seal coating. So kapok fiber shows inherent hydrophobic chlorophylltic nature, then kapok fiber has the great potential to be developed into an excellent oil-absorbing material. So as you can see, the design, we have two design picture here as we shown in the slides, which is the kapok fiber filter trap, which is made from the acrylic sheet also. The design of a filter trap with and without the kapok fiber as shown in the slides. This is a rectangular shaped trap made cut of acrylic sheets. It has two layers, which is the top and bottom layer. On the top layer, kapok fiber wrap in a net is placed. The kapok fiber is wrapped in the net so it does not fall together with the water into the bottom layer. Between the two layers, small holes are drilled between so to let the water filtered flow into it. So in conclusion, this trap serves as a filter to trap the oil. So we move on to the filtering process. As you can see, this is the diagram of our multi-stage oil trap. The filtering process is start from the left to right. So the water flows into the first chamber. So this oil trap works by the method of gravity. Since the oil are less dense than the water, the oil will flow up to the top and the water will flow down. The water then will flow through the pipes into the second chamber and the third chamber where the same process will occur, which is the filtering process of the oil. The last stage of this filtering system is that the water will flow out through the outlet pipe and to be filtered by the kapok fiber filter trap at the end of the chamber 3.
Our Kapok fiber filter will be placed at the end at the outlet of our trap, which serves as a last resort to filtering any fat and oil. Because as you can see, most of the oil has been filtered in the first chamber. Not a lot of oil will go into chamber 2 and chamber 3 and exit the trap. So the efficiency of our Kapok fiber filter will be able to filter a lot more oil over time. As you can see, the amount of oil is filling up in chamber 1 and not a lot of oil has been passed through chamber 2 and chamber 3. And there you can see how our filter will work.
We move on to the result and discussion. So this experiment, we have made an experiment to study the effectiveness of the kapok fiber in the filtering system. So we used 3 different parameters was used in this experiment. So we already set the amount of oil was set to 220 milliliters and the water flow approximately around 3 liters. So the different parameters is that the weight of the kapok, starting from 30 grams, 40 grams, and 50 grams of kapok fiber that we use. So this experiment used brightness of yellow color in the first chamber as the result from high, average to low.
So our first experiment, we will use 30 grams of Kapok fiber. Here's a picture of our 21 gram net that we will use to fill in our Kapok fiber. And here is a picture of our 30 grams of Kapok fiber filled inside the 21 gram net. So how this experiment will work is that we will fill in oil and water in through the chamber, in through the filter, and the filter will do its job to filter as much oil as it can. The excess oil that is not being able to filter by the coupled fiber will flow through into chamber 1, and most of the oil in chamber 1 will be flowed up on top. Our results will be determined by the amount of oil and color of the oil in chamber 1. So once the oil in chamber 1 is filled, the water will flow into chamber 2. And once chamber 2 is filled, the water in chamber 3 will flow. Here you can see the amount of oil left in chamber 1. And here's the amount of oil left in chamber 2. Not a lot, but it's still there. And once the water is filled, it will exit through the outlet. And here is a picture of our 30 gram Kapok fiber filter after experiment 1. Not a lot of oil has been filtered by the Kapok fiber. For experiment 2, however, we will use 40 grams of Kapok fiber instead. Here is a picture of Kapok fiber, 40 grams of Kapok fiber filled inside the net. Here is the amount of oil left in chamber 1. There is still a lot of oil, but it's not as much as compared to experiment 1. The Kapok fiber was able to filter a little bit more oil. Here is a picture of 40 grams Kapok fiber after experiment 2. Not a lot of Kapok fiber has been filtered, but it's still more than experiment 1. Experiment 3, we will use 50 grams of Kapok fiber instead. Here is a picture of 50 grams of Kapok fiber filled in the net. And here's a picture of the amount of oil left in chamber 1. A very little oil is left in chamber 1, which means a lot of the oil has been filtered by the Kapok fiber filter. Here is a picture of 50 grams Kapok fiber after experiment 3. A lot of the Kapok fiber was able to absorb a lot of the oil.
Okay, these are the results of our experiment. For experiment 1, for 30 grams of Kapok fiber, we can see in the picture that there is a lot of yellow color, which is very high. And for experiment 2, we use 40 grams of Kapok fiber, and we can see that the color brightness of the yellow color is very average, it's moderate. And for experiment 3, we use 50 grams of Kapok fiber, and we can see that the yellow color is very low, which is good. And over there, we can see our graph. The higher we use the higher the mass of the Kapok fiber, the more the amount of oil filtered until a certain point. So, why did we limit our Kapok fiber to 50 grams? It is because we want to preserve a steady flow of water and to avoid overflow. As you can see in the picture, in the red circle, the Kapok fiber, we set the Kapok fiber to 60 grams, and we can see that the water has been starting to overflow, and the water will eventually overflow into the open. Our conclusion is that this is a new design of oil trap. We use Kapok fiber as the main filtering material. We use 3 chambers instead of 1 chamber, and we've solved the problem faced by the restaurant, and we have helped to save our environment. That is all from us. Thanks for watching.